Periodic trends.
Structure of table. The elements on the table are located in such a way that there are 18 columns called groups or families. As we go down the families, the amount of energy levels in the atom increases. The rows, on the other hand, are called periods. As you move across the periods, the number of protons in each atom increases.
The trends poem. Let's take all the trends and break them into pieces. First, as we go down a group, the atomic radius increases. As we go across a period, the atomic radius decreases. Now to put more into our memory, let's take a look at ionization energy. As we go down a group, ionization energy decreases. As we go across a period, ionization energy increases. To keep things in an orderly manner, keep in mind atomic radius and ionization energy work in opposite patterns. Moving on, the interactivity between electrons and nucleus is measured through electronegativity. As we go down a group, electronegativity decreases. As we go across a period, electronegativity increases. Lastly, let's take a look at atom activity through reactivity. Metals reactivity increases as you move down and decreases as you move across. Whereas nonmetals reactivity decrease as you move down and increase as you move across.
Why do these trends occur?
Atomic radius. Atomic radius increases as energy levels are gained, resulting in the valence electrons being further away from the nucleus, having a higher repulsion shield effect on the outer electrons from the inner electrons, considering that light charge is repelled, resulting in a bigger radius. On the other hand, atomic radius decreases as the number of protons increase, increasing the effective nuclear charge. In other words, there is a stronger attraction force in the nucleus that pulls the electrons in closer, resulting in a smaller radius.
Ionization energy. As electrons are further away from the nucleus, when energy levels increase, they experience a lower effective nuclear charge, which is the attraction force of the nucleus because of the shielding effect onto the electrons. Thus, they are easier to remove and have a lower ionization energy measured in kilojoules per mole. As protons increase in number, there is a greater effective nuclear charge and attraction between the valence electrons and the nucleus, thus the electrons needing more energy to be removed, resulting in increased ionization energy. For every additional electron lost, ionization energy increases, considering how the effective nuclear charge increases as the protons outnumber the electrons, needing more work to remove the next electron.
Electronegativity. Electronegativity is the tendency of an atom to pull electrons toward itself in a bond. If an atom were to have a small radius and a large number of protons, it can exert a large force of attraction on the electrons, thus a higher electronegativity. If an atom were to have a larger radius, then the amount of attraction force on the nucleus exerts on electrons decreasing, thus a lower electronegativity.
Reactivity, metals. Metals tend to lose electrons in order to react. As you go down a group, the energy level increases, resulting in higher shielding effects that prevents the outer electrons to feel the force of the nucleus, which means it is easier for the atom to lose an electron and react. On the other hand, as you move across the periodic table, the effective nuclear charge on the electrons increases, meaning it is harder for the atom to lose an electron and react.
Nonmetals. Opposite to metals, nonmetals tend to gain electrons in order to react. The energy that the atom releases with each additional electron added is called electronegativity.
Since energy levels increase as you go down the table, the shielding effect is higher, which means that the nucleus needs to work harder to attract additional electrons. Likewise, as you move across the table, the effective nuclear charge increases and the attraction force between the nucleus and the electrons increases. Thus, it is easier for the atom to attract additional electrons and react.
And that brings an end to our presentation. Thank you for listening.